So today we're going to drive approximately, how long is it? 364 kilometers, and I charged my battery to full. But if we look here, even if I have a long range and charge to full, it's estimating that we will only have 8% left when we arrive in our destination.
But according to the Tesla website, the car should have a range of 560 kilometers at least, according to the WLTP driving cycle standard. How could it be like that? The computer in the car is really good to estimate the amount of energy that you will have left in your battery when you come to the destination. But how accurate is this actually? And what is the car's computer taking in calculation when it estimates this energy consumption? I have been driving electric cars since 2015. My first EV was the Nissan Leaf with a 24 kilowatt-hour battery. With so little amount of available energy, you learn that you had to economize with the energy if you would like to drive some longer distance. Fast forwarding to today, the summer of 2020, now I am a proud owner of a Tesla Model 3 long range. This car has a battery of 75 kilowatt-hour, which means that we have a huge range comparing to the Nissan Leaf. But it is the same thing with the Tesla Model 3 than with the Nissan Leaf. If you drive the car aggressive, use the acceleration fast, you will drain the battery faster.
So what is the car taking in calculation when it estimates how much battery will be left on your trip when you put it in the navigator?
Even if I don't have any source of it, I can assume that the computer takes the different height of the starting point and the destination point into the calculation.
But also one important factor is the weather. How is the weather situation? And I found out during my experience of electric cars that one of the worst, most consuming environments when driving a car, a EV, or probably also a fossil fuel car, is when it's windy, you have headwind, and it's blowing against you, and it's raining quite hardly, so you have a wet road where the car has to push the water away from the street. Then you have a really huge consumption.
So is the computer in the Tesla car also taking the weather as a factor when calculating the amount of energy needed to reach the destination? Sometimes, especially when you have really far to your destination, the car gives you this warning sign that you should keep a certain speed or not go above this speed in order to reach the destination. So I guess also that the speed limit that is geo-stored in the Google map is also put into the calculation. So if you keep to the speed limit, unless you don't get this earlier warning that I showed you, you will be fine in order to get to your destination.
Well, this car has a huge battery, and comparing to the Nissan Leaf, where I had to, for the drive of these 364 kilometers, I had to first fill up the battery to maximum, and then I had to stop 3 times for rapid charging the car before I came to my destination with an empty battery. In my Tesla, I can drive this stretch all the way, and that is really impressive.
At this time I switched the settings in the car from showing energy to distance, so I could see how much distance the car estimated that I had left. And yes, I reached my destination going through rain and headwind. But when I came to my summer house, the battery was really empty. Well, not really empty, but almost. But driving the battery down so low like this, you better be sure to have a destination charger at your goal for your trip. And here there is a socket that I can use for charging my car, and I installed it especially when I got my first electric car, which was a Nissan Leaf. Now I will use it again for my Tesla.
Okay, the car says it will take 23 hours and 15 minutes in order to not reach the 90% levels.
But already the next morning we had plenty of energy in the battery, so we could go for a shorter excursion. So even if you know exactly how to drive to your destination and have been driving there 100 times, I recommend you to put the destination into the navigator. And there is 3 reasons for that. First of all, as we have shown in this movie, the car will estimate how much battery will be left when you arrive at your destination. So if there is any kind of range anxiety, that information will kill it, because the car tells you if you will make it or not. The second reason is that if you would like to use the feature Navigate on Autopilot, then there is a requirement that you have a destination into your navigator. And the third reason is that if you are having some traffic jam or block in front of you, the navigator will reroute you the fastest way, even if it's longer. And that could very well be useful sometimes to avoid getting stuck in traffic. And there is a fourth reason also, and that is if you're driving on a longer distance and need to supercharge. The navigator will route you through the supercharger, and sometime before you're arriving to the supercharger, it will start to preheat your battery to an optimal temperature. So your supercharging experience will be as short as possible, so you quickly can go on the road again and continue your drive. Okay, but why do the WLTP driving cycle standards show that you can go 560 kilometers with my Tesla Model 3 long range, when I only managed to go 364 kilometers, and after that had an estimated range of 29 kilometers left? And what is WLTP actually stands for anyway? Well, it stands for Worldwide Harmonized Light Vehicle Test Procedure. Try to remember that. But this is not so worldwide, because in the States they are using the EPA range of a car, which differs from the WLTP standard that we are using here in Europe. The EPA range for the Tesla Model 3 long range all-wheel drive is 518 kilometers. But in the United States, you're using miles. Okay, so it's 322 miles. Okay, but probably you can go 518 kilometers or 322 miles or even 560 kilometers with the car. But then you have to drive on a flat road without any weather disturbance at an optimal outside temperature with no heating or cooling in the cabin, and drive in the optimal speed of maybe 80 kilometers per hour. Or what it is in miles, I don't know. But we have one question unanswered in this episode, and that is how accurate is the Tesla navigation when it comes to predicting the battery percentage upon arriving to a destination. So when I went back, I drove the full 363 kilometers in one stretch without stopping. For some reason the distance was 1 kilometer shorter when I'm going back home. Okay, never mind. When starting the trip home, the car estimated that I should have 13% left when I arrive in 4 hours and 5 minutes with a timestamp of 17:03. The weather was fair this time. I kept to the speed limit and the traffic was moderate, without any unexpected stops. So let's now see what the numbers are when arriving. I had 14% left of the battery and the time was 17:01. Or maybe 2. The actual distance measured by the car was 365 kilometers with a driving time of 4 hours and 3 minutes. The consumption was 159 watt-hour per kilometers. So let's compare the numbers. Well, that prediction was right on target by the Model 3. Less than 1% error both in distance and time, and only 1 percentage point difference of the remaining energy in the battery. If you would like to see some of my other long distance trip that I made an ultra long trip last summer to Poland. You can click up here, and if you would like to see my first long distance trip, you can click here, where I went to the northern part of Sweden. Until next time, have a great life.